Welcome back to another AP Precalc video. I'm Mr. Hibble. Today we're going to be looking at our last section of 3.13. This one is all about sum and difference formulas for our trigonometric functions. So, looking at our difference functions, we can just start by writing those down. If you have sine of two angles that are adding, maybe we call them A and B, what you're going to start with is sine of the first angle. You're going to multiply that with cosine of the second angle. But there is a little bit more to it. Since we are adding these angles, sine leaves the operator the same. But then the second part will flip. So now it's cosine of A times sine of B. Same idea with subtraction, sine of A minus B. It's the exact same setup. There's only one thing that changes for this, and now it's the operator. Again, for sine, the operator stays the same. Cosine, though, is a little bit different. It's very, very similar setup. If you're adding two angles together, that would mean that we start with cosine. But the weird thing about cosine is the function is grouped with itself. So cosine is grouped with cosine of both angles. The other weird thing about cosine is the operator is not the same. So when we have adding two angles, you're actually going to subtract them. Sine A times sine B. And then same idea just with subtraction now. You guessed it, like I said before. We know that the operator is opposite for cosine. And now we have our different functions. So what this allows us to do is find exact values for angles that may not be on the unit circle, or they just might not be on the unit circle. Whether it's for radians or for degrees, we can utilize this idea. So using this sine, then, we know we're just going to add our two angles here. We're just going to apply the formula now. So sine, this would be the top formula where they're adding. So sine of A, that'd be sine of pi fourths. That gets multiplied with cosine of B, which is pi 6. It's sine, so the operator stays the same. And then it just switches which one has which angle for the second. So cosine now has the pi fourths and sine now has the pi 6. Find each of those values, then we know on the unit circle, sine of pi fourths, cosine of pi 6. We know cosine pi fourths and sine pi 6. And now we just simplify. Notice both of these will have a denominator of 4. So since we're adding those, that would be a common denominator of 4. We can just combine that right away then. Square root 2 times square root 3. When you multiply roots there, as long as it's the same root, you're allowed to multiply them together. So that gives us square root 6. And the square root 2 times 1 is just square root of 2. From here, then, there's nothing we can do. You can't add or subtract radicals or roots when they have different values underneath. They would have to be the same values, so this is actually our final answer. Same idea with C there. You can start to plug in the different things and the different parts that you know. This would be our cosine subtraction one. One thing people generally ask is the x negative? Like, do I need to plug in a negative angle there? Well, no, the formula's already applied that idea for us. So when we have this minus x, you're just going to plug in x. The sign is already being taken care of in this formula. So using that formula, we plug in. Let's do that real quick. Cosine 5 pi fourths times cosine of x. Notice again how it's just x there. It is cosine, so we'd be adding now instead, and then sine of both of those angles. Simplify the parts that you can from here. So cosine of 5 pi fourths, that would be in the third quadrant then. And it is pi fourths, so we know that's root 2 over 2. Same idea with sine. It is in the third quadrant there as well, and it's root 2 over 2. And at this step, there's not really much else you can do. You might just try and simplify and write it in different ways. One thing I do notice is the root 2 over 2 is in both of these. So is our answer sufficient? Yes, because I can't change cosine x and sine x, so this could be your final answer. But because we have the same part in both of these, we generally like to factor that stuff out to make it look a little bit nicer. Negative root 2 over 2 times cosine x plus sine x. One thing we already talked about is why do we even have these formulas, right? And the answer is to find the exact values of non-special angles, right? We just looked at angles that were not on the unit circle. Pi fourths plus pi sixths, that is not on the unit circle. But we just found an exact value to represent it. Well, you can do the same thing whether you're given degrees or radians. You can start to apply these different ideas. When you have degrees, you would generally want to use an angle of 45. Definitely want to use an angle of 45 if your angle ends in a 5. The reason for that, the other multiples we know are 30, 45, 60, and 90. None of those would get you to have that ending of 5 by adding or subtracting stuff without the 45. So 45 is generally in there. Let's look at how this would work for sine of 105. Well, if I make this sine of 45 plus something, well, I know 105 minus 45 gives me 60. So now I'm just applying my formula. Sine of 45 plus 60, I would take sine, let's think in radians, maybe that makes it easier. So pi fourths plus pi thirds. And now we can just go ahead and apply our formula. So sine pi fourths, cosine pi thirds. If you need to go back and look at the formulas again, definitely make sure you do so. I'm just assuming we have those memorized at this point in the video. I know that may not be true. And then start to simplify again. Square root 2 over 2, cosine pi thirds minus cosine of pi fourths. We should also have the unit circle memorized at this point. That's why you'll notice I'm going through these values a little bit quicker. So then again, simplify square root 2. Common denominator 4, it looks like in this case. Again, when you multiply radicals, you are allowed to combine them. So 2 times 3 does give us 6. But now I cannot add and subtract those because the 2 and 6 are different. And now we are done. One thing I know some people struggle with is just trying to figure out what these angles should be. Well, again, it's multiples of these different angles. Well, for example, if I look at this one, we know that it could be 45 plus 210. And okay, well, what is that? Well, 210, I know 30 goes into 210, right? 3 goes into 21, so 30 goes into 210. Okay, well, that would allow me to make this cosine of pi fourths plus, well, what would 210 be? Well, again, if 30 goes into it, that means it's some multiple of pi sixths then. Well, how many times does 30 go into 210? That would be 7 times. Now you have this function in terms of radians. Same idea with sine. You could start to break down 285 into different ways using that same logic. I'll leave that one up to you guys. Let's continue. Let's look at a few more of these problems. So looking at this next one, same idea, but now we're in terms of radians and just how can we start to break these down. I'm not necessarily going to go through the full process because I think we can use formulas super easily and then evaluating on the unit circle. I know you guys can do that and we've seen it a few times now in this video. So instead, what I'm going to focus on is breaking down the angles instead. Here's what it says. If you're given radians, you could convert to degrees, or let's just think in radians, right? We know radians. If you're doing that, you want to find two fractions that have a denominator of 12 that add to the given angle, right? 7 pi twelfths, you can make that 1 and 6, 2 and 5, 3 and 4, etc. But realize when you're choosing the angles, you want to make sure that they are values that reduce with 12. For example, values that do not reduce with 12 would be 5, 7, and 11. All other values should be okay to use. I'm going to even include 1 there. We know 1 wouldn't really reduce with anything. Okay, so let's play around with this then. If I have cosine of 7 pi twelfths, you could break that down into a few things. The first one that came to my mind is I know 3 and 4 both go into 12. So why don't I just change this to 3 pi twelfths plus 4 pi twelfths? We know that would add to the 7 pi twelfths we need. 3 and 4 both simplify, so now this is just going to be pi fourths plus pi thirds. That's just simplifying our fractions. And then from there, you could apply your formulas. Let's look at sine of negative pi twelfths. This one, notice it's a negative angle, so you need to be careful about your addition or subtraction. You might choose 3 and 4 again, right? Realize there's a bunch of different combinations that can work. I know some people, when we went over this lesson in class, said they chose for A here, they chose maybe, what would be another one that works? 3, 4, let's see, 1 and 6 would not work. Maybe that was the only one that actually worked, because 2 and 5 wouldn't either. Yeah, maybe that was the only one. For this one, though, for sine, this one I do know has multiple options. I know some people chose sine of 4 pi twelfths and 3 pi twelfths. I got to make sure I do this in the correct order, though. So let me erase that. So if I choose 3 and 4 again, I could have 3 pi twelfths minus 4 pi twelfths. That's what it was. And then you could simplify both of the inside there. Realize different ones that would work on this. Maybe you choose sine. Let's think. What else could work? 8 and 9 would work as well. So maybe you said 8 pi twelfths minus 9 pi twelfths. Right? There's a bunch of different options that do work here, and you can see that now. Again, just make sure you reduce those fractions, and then from there, you're just going through using the formula. There we go. Lastly, let's go ahead and look at one more thing before we wrap up this video. Looking at number 6 here, this one reads that it's given sine of an angle A and sine of angle B. And angle A is in quadrant 2, angle B is in quadrant 3, find the following. And we're just going to look at the first one here. We're not necessarily going to look at this one. Let's use this space, though, for our diagrams. Notice at the top it does say sometimes drawing a triangle will solve all of life's problems. I know some of you don't agree with that, but it does actually make math a whole lot easier. One thing we need to remember, though, is what sine represents. Well, we know sine of some angle is represented as the opposite over the hypotenuse. Okay, well, if they give us that sine A is 3 over 5, that's giving us the opposite and the hypotenuse on our triangle. I know angle A is in quadrant 2. Let's draw our diagram. Here is angle A. They tell us that sine is 3 over 5. There's my opposite and my hypotenuse. We know this is a 3, 4, 5 triangle, so now we also know the adjacent. In quadrant, for sine B, then we know it's quadrant 3. There we go. We know that our angle is negative 15 over 17. Sorry, our ratio is negative 15 over 17. This one, we do need to use Pythagorean theorem to actually find the missing side. So negative 15 squared plus b squared equals 17 squared. 15 squared is 225. 17 squared, I don't have that one memorized. Let me find it real quick. 289. Start to solve from there. Just subtract it over. You get 64. Looks like this is also a nice triangle, a Pythagorean triplet. And we get -8. Notice that value does need to be negative because the x is moving us to the left. So let's also correct that 4. The 4 should also be negative based off these diagrams to make them actually work with the correct quadrants. So now from there, now that we know each of these, realize what you can find from these triangles then. The first one, we know that sine A is equal to 3/5. But now that we also know the adjacent side, I also know cosine. Cosine is the adjacent side over the hypotenuse. Same idea with angle B. We already knew sine B was -15/17. But now we also know cosine. Cosine is -8/17. And then from there, now that we know that stuff, we could start to plug into our formula. Sine B minus A. We know our sine formula starts with sine A, which is 3/5, times cosine B, which we said is -8/17. It looks like we are subtracting. Remember, sine keeps the operator. And then now we'd have cosine of A, -4/5, times sine of B, which is -15/17. And now just start to simplify. 3 times 8, well, that would be 24. Notice the negative with that 8. That would end up being negative here. 5 times 17 is 85 for our denominator. The second fractions multiplying will also give us 85, so I'm just going to extend our denominator there. But notice we have 3 different negatives included in this part. We have a negative times a negative with that minus in front. 3 negatives would mean this value comes out negative. 4 times 15 then is 60. Combine your values on top, and now this problem is done. Thanks for watching. Again, this one is just a whole lot of formulas. I'll see you guys next time.